Welcome to Rubber Duck Engineering. Tonight we're going to talk about rasterizing a circle. Hey, Dr. Barth.
We're gonna draw a circle. Draw a circle. Hey, Eric, how you doing?
I'm all right. It's been a busy week, which is why we're drawing a circle tonight and not doing ML stuff. But yeah, otherwise pretty good. Yourself? You cooked some pizza?
We had quesadillas tonight.
We
with
also
salsa
had
fresca
quesadillas tonight.
and guacamole and refried beans. It was amazing.
Wow, that's another level. We just had plain quesadillas and then I had some salad. But anyways, circles.
Circles.
So like 30 episodes ago or something like that.
Way back in the 70s.
In the 70s, we rasterized a line, and I think we talked at that time about maybe rasterizing a circle. And so tonight, in kind of a one-off, a palette cleanser, if you will.
An amuse-bouche of coding deliciousness.
Well, when we started the show, we had a rule, kind of like Fight Club. You know, the first rule of Fight Club is don't call it. Well, there's like the first rule of Rubber Duck Engineering is that you don't work on Rubber Duck Engineering outside of the hour that is Rubber Duck Engineering. And
I don't know how well we've stuck to that rule, honestly, over the course of the show.
But this week we stuck to that rule. So go us.
Okay, when we drew the line, we used a super fancy line drawing algorithm that was beautifully anti-aliased. And I think we mostly got it by the end of the episode. You can go back and watch that episode if you want to like check up on us.
I have the code. The codes of destiny. That is the code.
Hi, welcome to the show. I think this O is like the minimal wave, so I'll give you a minimal wave back.
No, I think it's a circle.
It's the circle. It's the circle we're rasterizing. Big circle. Doodle circle.
It was fun searching for public domain images for circle for the background for the YouTube thing tonight, because there's actually quite a few, beautiful circle images out there. So,
isn't it Da Vinci who like drew the circle, decided that was like the test of your artistic ability?
I can believe it. Anyway, so we did rasterize the line. I can actually show you that because I have.
Oh, maybe HAL 9000 has the best circle. That's you do win. Is that like a emoji for some sort of like traffic control from the EU or something?
I thought all
the EU, they have all these like
Japan.
They have all these shapes for like they're like I don't know what they mean, but they somehow control all the traffic in the EU with like these circles and lines and stuff. I try not to drive there because I'm just gonna like drive on the wrong side of the road, then the wrong way in a one-way street. It's just gonna be horrible.
I lost my turn. Oh, I was gonna show you. I didn't set up my second. Oh, can you bring my thing forward? I bet you can.
Oh, I can. You want to bring it forward?
Yeah.
To the code machine?
To the code machine.
Boom, I did it.
You did it. So I can't see you anymore because I don't have my second screen set up tonight, but maybe I'll do that during the show. So this is what we rasterized last time.
You've been following since episode 3? Oh, wow. Thanks for joining us. So glad you enjoyed it. That circle means you can drive forward, but only in reverse. Yeah, I guess that's how you go the wrong way on a one-way street, is you point the car in the right direction and put it in reverse, and then you drive backward.
I'm getting my second screen so I can see what you all are talking about.
Living life on the edge, yeah.
Anyways, this is what we did last time. I'm not sure this is quite right.
I don't think we quite got it right. We were pretty close, though. But the point is, this project is like a useful test harness. So I think we're going to try to reuse this test harness to draw a circle.
Okay. Yeah, so, and you said you have an algorithm. A less fancy algorithm.
I have a Wikipedia article. We can start reading the Wikipedia article and learn about circles from first principles.
Okay. 1 second. I'm getting.
I don't think these are the right traffic rules. Maybe Hal, you're trying to get me in trouble.
There we go.
Do you have the link to the Wikipedia article, or do you want me to fetch it for you?
My second screen just ran out of battery, so whatever. Technical difficulties. We got this, folks.
All right, if you just search for wiki, I can put it in the chat if you want. Here you go.
In the chat. Show it. Midpoint circle algorithm.
Midpoint circle algorithm.
Okay. And you can make me full screen again.
All right, here we go.
In computer graphics, the midpoint circle algorithm is an algorithm used to determine the points needed for rasterizing a circle. Okay, good. Bresham's circle algorithm is derived from the midpoint circle algorithm. Okay. Algorithm can be generalized into conic sections.
Yeah, so if you look in this picture here on the right, you'll see that there are different colors. There are 8 different colors for like 8 slices of pizza. And so I think it will draw 1/8 of the circle.
Okay, makes sense. Okay. 150 concentric circles drawn using the midpoint circle algorithm. Okay. Article may be confusing or unclear to readers. Okay, good. That's
Unlike every other Wikipedia article, which is crystal clear.
At each point, x squared plus y squared equals r squared.
That's just the equation of a circle.
Yeah. This can be thus arranged. To rework the next point equation to a recursive one by substituting x of n plus 1, x squared of n plus 1 is equal to x of n minus 2 times y minus 1.
Mm-hmm.
Okay.
Then I presume you plug that back in to get y.
Variant with integer-based arithmetic. Wall of math. Drawing incomplete oxidants. Okay, so we're going to pick which. So we're not doing any aliasing at all in this.
No, I think this is an alias circle algorithm.
Okay. So we're just going to plug this in?
Yeah, I think we're going to plug that in, basically walk around like from point to point and basically plot that function for 1/8 of the way around the circle.
Okay.
We could try that and see what that does.
Yeah, seems pretty straightforward. Let's try it.
So I can start, let's see, if you go back to VS Code, we can start typing this in somewhere. So we have our draw line function. Why don't we add our draw if you want to scroll up to line 15.
Okay.
How fast I typed that? That was Copilot.
Oh, that was Copilot?
Yes. It actually completed a totally reasonable draw circles function. But that just relies on Canvas drawing the circle, which is no fun.
It's cheating.
It doesn't know that we want to draw it by hand with like stone knives and like rocks.
Yeah, because our stuff is in pixels plot.
Right. So I think it's these pixels. So we'll take a start offset and a color.
Yeah, we should go look and see how this was put together, right? So this is my app. We have our pixels. That's like a array. And we do offsets. And we do draw line with the pixels. And then we have a pixel view.
So the pixel plot like start.x or start.dx, start.dy, color, and then 1.0. And we'll see if we can get that to work. This is mad. Oh, this wants an integer. So let's do like round, I guess. Or this is gonna be like an integer-based algorithm. Let's try it just like this, round. Okay, so let's see if we can get this
correctly.
Oh, I was just trying to like draw a single pixel to make sure that we remembered how this thing worked.
Okay.
So then I was going to go down. I was going to see where we call draw line. I was going to call draw circle instead. Okay, so I'm here on line 97.
Okay.
So instead of calling draw line, I'm going to call draw circle. Pixels. I'm really enjoying using Copilot. It's quite an experience. Okay, let's start at 2.0 and 3.0, and then we're not going to give the end.
Okay.
Yeah, let's see how many. It's a 10 by 10 grid. So why don't we start somewhere near the middle?
1 second. I've got to pull that. And
pixel view.
Great. Okay, I think things are back to okay. I'm here for you. I have my 2 screens set up again. Sorry about all that. Pixel view had a start and an end. Oh, because it was drawing the line.
Yeah, I'm going to rip that out just because I don't think we want that.
Okay.
Which I guess we'll sort of break the other demo, but that's fine.
Okay.
Start and end. Don't want that. Want this. So painter, start and end. Don't want these. Then do that. Okay. So did we succeed in drawing a pixel? We're out of errors.
It did not hot reload for some reason. Okay, we're drawing a pixel.
A pixel. Okay.
I do wonder if we need to move to fancier anti-aliasing, but we can get that after we have more than a few pixels drawing.
Okay.
You were saying?
We could try to draw the next pixel.
So what is this? Why is it drawing lines? Oh, this is the grid.
Yeah, it's just drawing our beautiful grid.
Okay.
So now we need this equation from Wikipedia. So I'm just going to try to type the equation into code here. So the equation was x of like x next is equal to the square root math.square root.
What is this? Oh, this is background?
It has a beautiful picture. Current x minus 2.
I'm not following your
y.
Your fancy typing here. Next x. Oh, I see. This is okay.
Get a double here because it's going to
I think
change.
our x and y are float algorithms, but yeah.
That's okay, right? If they're float?
I think. Let's see what our midpoint circle algorithm did. Remember, it had an option for an integer algorithm.
Oh, should we try that one?
Oh, let's see. This is a variant with integer.
Let's try the floating point one and see where that gets us.
Okay. X squared of n plus 1 is equal to r squared minus y squared of n plus 1.
So it was that last equation there that I took. So rework the next point equation into a recursive one. That was the equation that I just tried to type in.
Okay.
Can I explain how you can compile C code to Dart compiler? I think there's a foreign function interface. If you search for Dart FFI, you can compile your C code and then use Dart FFI to call into it from your Dart code. I'm not sure if that's what you're looking for, but that
definitely should work. You just have to compile a .so on a per platform basis to be able to talk to it from Dart FFI. But I believe we have some examples. And people have done a bunch of this with Rust too, talking from Dart to Rust. You were saying, sorry?
Oh, I wasn't sure when to stop this iteration, so I'm just going to do it for 10 times and see what happens. How do I get y next? Don't I need the seems like the radius is important, right? Oh, y next is there, right? So y next is then the square root of
y plus 1.
Y plus 1
It's the
squared.
previous y squared plus 2 y plus 1. So when you say x next, is this x squared next?
Oh, well, that's why I put a square root.
I see.
Or what was the equation? I lost it again.
So let's see. Y squared next is equal to
Times
y plus 1 squared.
2 times y times y, and it's 1.
It looked like you could either do
It's weird to me that the like
y next is equal to math that's square root of y plus 1. That should be it. Is that right? Because it's this one, right?
Yeah.
Oh, it's just y. Can't you remove the square on both sides? No.
Yeah. Something's going wrong here. Like there's no r in this equation. It seems like r is a very important factor in the circle. So there's r in this equation under here, where it says x squared equals r squared plus, minus all these things.
Well, I mean, as you said, the square, right? So for each point, the following holds. So we could.
I feel like I'm missing something very basic from this equation.
We could compute y from x.
Well,
right?
we have like xn and yn, right? And we have r. And we're trying to compute xn plus 1 and yn plus 1. And I'm sad that these equations don't include r, because r seems like a important it seems like an important factor of the equation.
I agree.
Oh, we can try this.
Next point equation. Well, what is this relationship going to be? This is x is equal to x squared. What?
We can try it. Let's try it. Like, what's the worst that can happen?
Okay.
So then we say x equals x next, y equals y next, and we'll do that for 10 times. And we'll see.
Maybe your next was more clear than my y xn anyways, but
I think it's supposed to be like this is better style, maybe.
This is dark.
It's confusing when you switch languages all the time. Okay, why don't we run this and see what it does?
Whoa, what did it do? Okay. Unsupported equation, infinity or nan to int.
Oh, okay. We did something really bad. Hi, thanks for joining us. Oh, don't simplify the equation, the x squared, to show it's plus or minus. That's true, but that's just going to depend on like which direction we're going around the circle, right? Like if we were to do the minus solution, we would walk around the other side of the other direction or something. What's the matter? Something got to be infinity?
Something got to be infinity. I mean, we could also just print.
Well, we're in the debugger, right? What does the debugger say is going on?
We are in the debugger. Infinity or nan to int. Okay. That's the exceptions. Show me the locals. X is nan. Why is it nan?
Maybe we took the square root of a negative number. So maybe that's what they're saying. Maybe we need to say like math.abs. That's not a math function. It's just a function on number.
Every language does that differently. Where the math functions are.
you want to try reloading then and see if that at least
Yep.
doesn't crash?
100% less crashing.
All right. So that to me strikes me as a circle with infinite radius. Otherwise known as a line. Congratulations, we made a line.
Because the radius is missing from our equations.
Yeah, so the radius is missing from our equation. So, but that equation has the radius in it. Should we try that one?
This one right here. Yeah.
Okay, so let's try that one. So that says that, what does it say? X next should be
related to y.
Oh, we do our like square root thing. So r squared minus y squared. Y times y. And then what was the other thing?
This one does it. How do you get...
Oh, but we don't know n plus 1. That's why we have to do this. Well, I guess we do know y plus 1. We just computed y next.
Well, so
that's 2y.
I see. You're saying that y just linearly increases indefinitely, and x is then the only thing that's relating to the radius?
You're right. You can have like one pixel per y, and then you're just moving along the arc. So we need to define a radius. So let's define a double a radius of 5.0.
Sure. So in this one, fine, yeah.
For const. Okay.
We'll get to that in a minute. All right, let's go back to our code here. So which one are we computing first? This is y next. So y next completely relates to y.
Yes, I think I'm not quite sure why r canceled out. That doesn't seem good. But yeah.
Well, so we could start with this. That's the y next. And then the x relates to r.
Mm-hmm.
Where this is, I know x next is equal to math root of r times r. Oh, I see. You did that.
Well, you're doing it a slightly different way, but I like the way you're doing it. Well, let's keep doing it that way. If I undo, can I get yours back? Yeah, I can get yours back. So you were saying r squared minus y next squared. Since we computed y next, why not use it?
Yeah. Well, that's what I was. But it doesn't make x next dependent on y next.
That's fine. Let's try this. What does this draw?
Oh yeah, it does right here. For the next point, x next is equal to y next, right? X.
That makes
x
sense, right? That to me looks like the equation of a circle.
Yeah. All right, let's try it. Range error.
Oh, we walked out of. We got too big or something.
Oh, plot. Yeah, fine.
Let's just make the thing really big. Like let's, instead of 10 by 10, let's do like 100 by 100.
Okay. And still be at like 50-50 or something for our midpoint.
This could give us a bunch of space.
Should our we could figure out what our y is, but our y could just be this could be like
we need to figure out the termination condition for the loop.
Whoa.
Still sort of a straight line.
Okay. I think this is time for us to put up our
we have no idea what we're doing.
Correct.
I got the banners. Yes.
In case it was not obvious, we have no idea what we're doing. All right. I feel like we've gone up the wrong direction.
I think we're way overthinking this. Like, what if y next was just y plus 1?
Just looking for. Midpoint algorithm using only 2 integers and instance. We should be able to 8-way symmetric. Fine.
Mm-hmm.
That's what we're doing. Circle equation is, yeah. X plus 1 is equal to YC. What the hell's YC? The square root of whoa.
What is YC?
Candidate, maybe?
Oh, I see. Y candidate. Okay. Keep Y, decrement Y. Okay. This is like integer rounding.
I feel like we've done this several times now where we go to Wikipedia and we find some code and then we decide the code is wrong.
Wikipedia, I think it's giving you a way more theoretical presentation of what's going on. And we're looking for a much more practical presentation.
All right, so origin circle at radius. RS2 is equal to radius times 4.
So yeah, another issue is that we're not drawing around the origin, which we could. That could be messing up all of our math here. Because that circle equation is really about delta from some origin.
Yeah. All right, so we plot an 8 while x is less than y. X squared, maybe this is what that is. It's equal to x squared. All right, this is also not super helpful, but I suspect if we start at this.
Do you want to try copy and pasting that code into Dart, and then we can start by relieving it of its vowel drought?
I didn't understand what you said, but sure. Oh, I see. It's vowel drought.
Yes. So let's just start giving these things actual names here.
Oh, plot
8. Okay, plot 8 we can do.
Plot 8. So, what the hell's plot 1?
Well, plot 8, this is like plot. Our pixels plot is plot 1, right? So.
Okay. Our pixel plot doesn't take integers, but sure.
Well, we can fix that. Okay, and then we want to pass in color, and 1.0 is our intensity.
Well, why don't we just add a plot 1 that does that? But go ahead.
Okay, sure.
Right, we can just save ourselves a ton of typing. I was talking with a mentee about this week. The idea of that sometimes you have a dependency that you have to replace, and you have to go through the exercise of implementing the shim layer.
Right. So this is, let's make this origin, and then let's take in double radius as an argument, right? That's a much more sensible contract for this function.
Okay.
Then we want to say this is really x plus origin dx.
Yep.
Round, right?
Yep.
This is really y plus origin y rounded.
Why is it always only 8 pixels? Like, oh, this is the unit circle.
Those are all the pizza slices. So it's going to walk around the pizza slice.
These are literal pixels. This only draws a unit circle.
No, it's going to draw a radius circle. But what's happening is every time it does a bunch of like arithmetic, it wants to put 8 pixels in the grid, 1 for each of the 8 pizza slices.
But I'm saying that what if we've scaled the circle up? Like this algorithm will only ever draw 64 pixels, won't it?
No. It's just going to draw every time it wants to draw. It'll draw 8 pixels at a time, and then it'll like rotate slightly, draw 8 pixels at a time.
Okay, I'm willing to give it a whirl.
Go back to the Wikipedia article with the
this one.
This one. Go up to the top with the animated picture. You see how it's drawing 8 at a time? Every time that the animation is ticking, it's putting in 8 pixels, 1 of each color. This is the plot 8. Plot these 8 pixels.
Oh, that makes a lot more sense. Okay, fine.
Okay.
Yep. All right. That makes a ton more sense. Okay.
All right. So let's make this plot circle. Well, this is just our function. We don't need to for that.
Yep.
Okay. So.
Wait, we need to convert these to ints. But yeah.
Convert this to int. Okay, so we need to take our int final int radius equals radius dot round. Okay.
I don't know if it allows you to change. Does Dart allow you to change types?
Okay, we're gonna make it an R. How about that?
Okay.
Okay, R. This is R S squared. So I don't know what the S is. This is definitely squared.
It may just be R. Yeah, I think it's just R. The S, maybe the S2 means squared in this logic.
But this is, it's like clearly R squared times 4.
Well, I'm just saying I don't. Oh, I see what's the.
This is RS squared. I don't know what M2 is.
The vowel drought.
Vowel drought. I'm just trying to understand this. I don't know what M2 is. I'm going to put an underbar in there as we don't know. This is took RS squared. Minus 2 times the radius. Okay. XY. R squared. This is candidate. So this
Maybe
S
it's
in here.
fascinating to look at Skia code for this. I expect it'd be difficult to find.
Okay, so plot 8. While x is less than y, advance to the right. So this is again squared. I wonder what the s is. Okay. Advance the x. Okay. This is y candidate squared. I'm just going to take out all the s's because everything has an s. I'm tired of your s's.
But it's y r squared times 4. I don't know what the times 4 is for.
I don't know what the times 4 is for either. I don't know. Okay, fine. I'm not going to take away all the s's. Okay. Candidate squared. I think I had an s in it. I really wonder whether there was a time when it was really expensive to have long identifier names. Or like, how did this style of
I don't know.
M1, okay.
You know what? I bet it predates autocomplete.
Oh, so like your fingers would get tired typing it all or something?
Yeah, just a lot of typing, right? But these days, obviously, you just start and boom. Also, maybe keyboards were worse then. Back in the dark ages.
So this is sad. Oh, I did something wrong.
What's the RX? Why is this taking? Oh, I see. This is like the current x squared.
Okay. Yeah, I don't know why this has to be. This is like a carried. Like, I think it's maybe a C style or something. Like, this is not carried through the loop.
Oh, I see. Yeah. Wait, what is this x squared m1?
I'm not sure. Let's try running this, and then I'm interested to learn more about this code by studying it. I'm curious if it draws a circle.
Why is it sad at us here?
Just because it doesn't like the way we've written the underscore.
Okay, fine. All right.
Let's have radius, I don't know, 10.
Why is it sad about life? Unused import. No Dart math for you.
Okay.
Non-constant. Print calls. Steep.
It's fine.
Okay. Oh my goodness.
It's a
That
circle.
looks like a circle.
Okay.
Such circle tech.
I want to make the radius bigger.
Okay.
I don't know why.
I mean, this is Flutter. We could just simply add a control that does that.
Okay, we could do that. I made it 20.
You did, in fact.
Okay. I think the vertical bars are really outlived their usefulness at this paint grid. I don't want to paint the grid right now. Here we go. Beautiful looking circle.
Yeah.
Do we want to try to understand what this code is doing?
Sure.
Okay.
Where do we go?
Can we make a commit? Like, I feel like we should commit. Like, we have a working thing. We're gonna like totally mess it up. And I think if we have a local commit, we'll be very happy that we can go back to it.
Okay, what are we doing? We got changes 35. Oh my goodness. Hold on, I gotta clean up our commit here.
Hey Giffy, thanks for joining us.
Hardware Mac OS, yes to all. What's we got? I had to regenerate Windows something because I changed versions of Visual Studio installed.
We can just commit those in a separate commit. Like those seem like good things to actually.
Oh, I see. You want me to? Okay.
I do this all. You know, but I'm just telling the audience that I use like local commits extensively. Whenever I make any kind of progress or get anything working at all, like commit. Like I don't want to lose it because I always break things. I know like editors say they have like infinite undos, but I don't trust them. For some reason, I trust Git more.
Okay.
Okay. So
all right, we're gonna go stare at the code and figure out what the heck it does.
Okay, I totally get plot 1. Let's get rid of all this chunk up here.
Yep.
It's not working for us.
Plot 1, understand. Plot 8, I understand. What is this?
The developing with Copilot is just wild because it'll just like suggest like entire like stanzas of code that kind of makes sense. Like look at the stanza of code that it suggested up here. Like it totally makes sense. Go from like scan through the entire unit square. If you're inside of the radius, fill in the pixel.
Ah.
Like it's totally like it drew a solid circle. That's not.
I have my Copilot disabled at the moment, so
it's still like a toy for me. Like for people watching in the future, Copilot is still free. They haven't turned on the like you have to pay for it yet, and so it's really a adventure.
So if you just type if you just type the comment, draw outline of the circle, will it like?
I mean, do you want me to try it?
Yeah.
Okay. Draw a circle outline.
I thought you just did it by doing comments. Don't you like talk to it in comments?
For some reason, it's going a line at a time right now instead of suggesting a whole. No, it doesn't like that.
Huh.
Anyway.
Yeah, it's fine. All right. So maybe stroke circle or something. But anyways, so what is this thing? This is the thing to compare the candidate against. And if it's less than it,
so this is like an integer. So I think a big difference between what this is doing and we were attempting is we were trying to do a bunch of floating point arithmetic, and this thing is very clearly working in integer world. Yeah. So it's going to loop and it's scanning across X, and it's trying to figure out like should it decrement Y. That's its big question in life, right? Mm-hmm. And this is like some kind of threshold for like moving on to the next one.
The Wikipedia article had an integer version.
Yeah,
not helpful.
This is like math.
Okay, Wikipedia fail.
Okay, but let's understand. So this is some sort of threshold value. Okay. So this thing is only used to compute this threshold. This is r squared. R squared times 4r squared. Okay, so this is
it's 2r squared.
It's 2r squared. So it's the diameter squared.
I don't know why we care about that, but sure.
Okay, but here's 2r, right? So 2r squared minus
2r
plus 1. So this is only used here, right? Just for the sake of my sanity's sake. Oh no, it's used elsewhere as well.
So that was this. y squared plus 1 is y squared plus 2y plus 1.
Oh, so this is probably r plus 1 squared. Like, okay, r plus 1 makes sense, right? So like you're trying to figure out, are you with like
Yes, that is r plus 1 squared. Yes. Okay. Yeah, so this is
there's like an
so
outer
you're
and an
saying
inner calculation that's going on here.
this is just like some, I don't know why this is 2r squared, right? And this is,
Well, there's like a parentheses in there, right? Like it's not 2 times r squared, it's 2r squared.
fine, we can leave that as whatever, but so this is 2r.
And you think that this is 2, you think this is r plus 1 squared?
The thing squared. Yeah. Yes.
Squared?
Caret
Is that
2.
right? Like why isn't that just r squared?
It's this. Or it's y plus 1 squared. Oh, no, it's not.
It's not. Okay, let's keep going. So x, we start at 0. So we're going to march on the x-axis, and y starts at radius. Okay, so we're out. We're starting on the circle, sort of at the like linear point. That makes sense. We draw that point. We love that point so much. Okay, and then if x is less than y, so that basically says once we hit the edge of the pizza slice, that's like the y equals x line. Stop. So that makes sense. Okay, so now advance to the right.
So hold on, I want to walk. So x starts at 0, okay, and y is at r. Okay, so we've gone vertically straight up to the point.
Yeah, you start at the unit circle. We're right at like North Pole.
And while we're advancing x, so we're going along the x-axis, and while that is less than y, which starts at the radius.
Right, so the x equal y line will be the line that at 45 degrees out from the origin, right?
Mm-hmm.
So that's the boundary of our pizza slice. So we
go until we that's hit dividing us into the octets or whatever.
The octets, hence the plot 8. So that makes sense to me.
Because we're always drawing out from an axis line and then mirroring, right? That's
right. We mirror it 8 times. That's what that's doing.
This is the 8x mirror around the various axes.
Correct.
All right, so okay. So this is imagining we're drawing, again, we're starting at the North Pole as you described it, and we're drawing along the pizza slice until we get to the
we're drawing along the crust of the pizza until we hit the edge of the pizza slice.
Yeah. Okay. Got that. Yep. That makes sense. Okay. So advance to the right.
So why is this advancing to the right? So this we saw in Wikipedia, right?
Mm-hmm.
This was x.
X squared is...
It's wild to me that this takes both the x as input.
It's the previous x, right?
The previous x and the previous x squared plus 4.
Well, there again, that's 2 squared, right? Because there's squares going on here. But why is this 4x plus 4?
Can we look in the Wikipedia article to try to find an equation like this?
Like it could come from...
Doesn't look like any of those things, does it? This is a super... I don't quite understand this. So let's try to think conceptually about what this is doing. We're always going to move 1 pixel. And what is this computing?
Well, so let's actually ignore this for a second.
Okay.
This moves our x.
That makes total sense to me.
Right? And this potentially is moving our y. Right? So we're moving across, because remember, we're drawing the upper right pizza slice.
Yeah, so we're going to decide, so we're going to keep going across until we decide we want to move down 1.
Yep. And so the question is, do we move down 1?
We move down 1, we pass some threshold, which makes sense.
And the question is, that threshold is y candidate is the RS squared.
Yeah.
Which y it's times 4, I have no idea. But so r squared minus x squared.
Yeah, so if I were inventing this algorithm, I would try to figure out like where is the next no, I don't know. Let's see. And the threshold also gets updated here. Like when you make this step, you update the threshold based on the old
Of course,
y.
because you just moved a pixel down. Now you're what's my next pixel threshold? That's what this is. This is the ys squared m1 is the pixel threshold.
Mm-hmm.
Right. So the y candidate is the it's like the squared threshold or whatever. Right. So the y candidate is in squared territory, and versus some squared threshold. When we're past that, we moved down a pixel. But why do we get up into like +8, -8? Like these mirror each other, right?
What's fascinating to me is that r has only ever entered the equation through this line here on line 36. This is the only place r appears in this algorithm.
It just starts.
Well, that's not true. No, it appears here.
Well, so these are mirrored, by the way, right?
Those are mirrored. Okay, that makes sense.
X squared and the y squared.
Right. So that's somehow okay. So when we advance x and we advance y, we do the same stepping equation.
Well, they're mirrored in that this is a minus. We're minusing 8 times our y plus 4.
That makes sense because x is going up and y is going down.
Because x is going to the right and y is going down in our normal.
But like, what's weird to me is like, why isn't this just x squared? Like, can we try that? Like, what goes wrong if we replace this actual x squared?
You'd have to also do the y as y squared.
Yeah. Let's just try this for fun, right? X squared.
Well, if they don't mirror, they're not going to work.
Yeah. But, so then this thing appears
also, how
here.
is this ever going to... Okay. Yeah, do you need to keep... You don't need to keep. This did not need to be C-style out there.
Absolutely not. But I just want to see... So this is... And what about we just make this r squared?
Right. This is just an int for when we come back. This is dead.
So this is... Let's just make this candidate... Y candidate squared. And I'm not sure what to put here.
Let's just make this r squared. But it can't just be r squared. Because it's some adjustment.
Yeah, this M1 is mysterious. Can we go back to the page that taught us this algorithm? Mm-hmm. I'm curious what M1 is.
I could have also read the text, because I didn't read the text.
Okay.
Rasterizing rules matter. Pictures are located between coordinates.
Right. Where the circle is algebraically, position x plus 1. Right. Where it is, so... Okay. That makes sense. The circle equation is that. I got that. From that we can derive the equation of point 1 is r squared x plus 1. Yes. So that y candidate makes sense. We can compare this value to the midpoint. Y. Okay.
Y minus a half. Right.
Yep.
If the y candidate is greater than current y minus a half.
Okay, so let's try just implementing from this description, right? So that go back. So the
So
this is saying that
so comparison positive. Yeah, so we want to get to positive. So we do y candidate squared, which is equal to y.
So y candidate squared is going to be this minus x, but it's really x plus 1 squared, right?
What's the x plus 1?
Isn't that what the page said?
Oh, I see.
Okay, so that's our candidate.
This ends up being y squared
So
minus
computing this just the way they say to compute it, which is y minus 0.5 squared.
Here. I think they're getting into it right here. So what do we do about the y minus y squared minus y plus 1/4?
Oh, so they double everything.
They factor of 4 to get rid of this.
Okay. So the s's are just this whole thing multiplied by 4, so you can do it all in integer.
Yep.
Okay. So let's try it that way, right? So this is the radius. This is like 4x.
Yeah.
Like if this is r squared. Like
it's r squared times 4, or 4r squared. R squared quad, sure.
Yeah, it's like r squared in quad land. Okay, so that makes total sense to me, right? This totally looks like r squared in quad land. So then what is this? This is r squared in quad land minus,
this is the negative 0.5.
Oh, this is the negative 0.5.
And this is the plus 1/4.
This is r squared threshold. R squared.
So this is
threshold in quad land.
R squared minus 0.5 R plus 0.25 times 4. It's 4 R squared.
Right. So this is 4 times x plus 1 squared, right?
It's just 4 times. Yeah. I mean, but you can also just write it this way, right? X plus 1.
Okay. Why does it matter? Oh, this is not supposed to be an int. This is 0. Very clever to do everything in 4x to avoid all the floats. They're like the old school computer people were like amazing at avoiding floating point because they didn't have floating point operators.
Well, now we have GPUs, which are like, we eat floating points for breakfast.
Yeah, it's like integers are slow. Like, can't you just like vectorize this on a GPU and draw a circle, please? Okay.
Yeah.
So
I remember when my machine, and I don't feel that old, when my machine did not have an FPU or a daughter card or whatever they called it.
Well, there was like a soft FPU. We were having to deal with that. Where like you have to detect if soft FPU was on, and then like avoid all floating point math. You use like this horrific square root approximation.
Yes.
Okay, so now let's look at this. So this makes sense, right? The candidate squared in quad land is the r squared in quad land minus x squared in quad land.
Yep.
Makes sense. And then what was the right? Oh, I deleted the this. Okay. And this is going to be, again, this is just going to be 4 times y plus 1, or y minus 1, I guess, times y minus 1.
Okay. Y squared candidate squad. Okay.
I need the threshold.
Y candidate squared? Because it's y candidate squared quad is what you want.
Oh, I messed this up.
You wanted threshold. This is threshold, right?
That's threshold, yeah. Okay, let's see if that still draws a circle.
Hold on, this is Y. And this is
Input space. New Y squared, the circle equation. Okay. So this makes sense to me. Let's see if it still draws a circle.
okay. I mean, we have no idea. Let's change the radius and see, just to make sure that
Sure. What radius do you want?
Although we also could use the power of Flutter here. Where's our main or whatever?
You want a widget to control this?
Yeah, we could just like put a widget. This is not that hard. Hold on.
Line 137. What do you want? Like a what is it called? A slider?
Sure. And then we're just going to need a set state on something, right?
We need to like stack these things or something. Stack.
Mm-hmm.
Children.
I don't know if you want to stack, but sure. Stack's fine. Column would be fine too.
Whatever.
And then we're going to make this stateless or stateful.
Yeah. You can do the light bulb. Do your light bulb.
Okay. What is it? Float? Int?
Yeah, double.
Full radius?
Mm-hmm. Unchanged. Figure it out for me.
Was that Copilot did that?
Of course. Oh, it's a radius though. You think I can type that fast? And then there's like min and max or something, right? Like min.
Yeah, I'd have to look. Slider.
In max 30. We don't initialize this thing like 5.
We changed stateless to stateful. We started
slider now.
No, we're still.
Where's our slider?
Somebody's mad at us. Nope.
Yeah, the light bulb is great. Light bulb is my favorite friend.
What?
I feel like everyone beats up on Microsoft Word for having Clippy or whatever. I feel like if Clippy was actually helpful, it would be useful. Like I think it's the eyes. Like the fact that it has eyes means it can it gives you a little bit too much personality. But light bulb doesn't have any eyes, and so light bulb just solves all my problems. What's the trouble?
What is wrong? It's sad at the world. No material widget found.
Oh, okay. Let's put a material widget.
Do we not have a scaffold or something?
Yeah, we don't have a scaffold. To just wrap the stack in a material.
On it. Wrap in. Are you doing it?
Yeah, go for it.
Oh my goodness! What happened?
More comments. Insert more comments. Fewer comments. Insert fewer comments.
What's going on here? Oh, we need more parens.
Friends.
No, it should auto format once we get the right number of parens. We got to follow the colors here. We're still missing one.
Okay. Oh, there you go. Why is it indented funny? Oh, we need more comments.
Yeah.
Insert more comments.
Oh.
This is the problem with multi-editing. Okay, now it looks beautiful.
I don't think I'm as helpful as Copilot here.
Beauty has been achieved. The only help I'll get is in C, is to disable the red screen.
Oh, there we go. That's what we needed in life. No.
No go?
What's why are we?
I call it set state. What did I do wrong?
Well, we're not passing the.
Oh, this is repaint. Oh no. Can I show you my favorite hack?
Sure. Oh, there's so much.
Why
You're
is
just
this
gonna give it a new key every frame. Be like, you're different.
Okay. Global key.
Maybe.
Object key. Object. Take that. I like it.
What is it complaining about? Creates key. Prefer const. Oh
No, don't const.
don't const it.
That'll mess it up. No.
I think your hack. Okay, we should.
That was not actually the problem. Oh, you know what the problem is?
What's the problem? Speak to me.
The problem is here on line 142, where we don't pass the radius.
No, that'd be cheating.
Why can't Copilot find that for me? That's why I have a Copilot.
Oh, look at that!
Oh my god!
Oh, it's pixel glory.
But okay, can I say something? There are three.
You can say whatever you want. It's your show. What?
There are 3 circles on the screen right now. One of them is beautiful, and it's the one drawn in black.
It just brings me back to like Mac OS. Like I remember Res Edit.
It looks exactly like Res Edit.
Oh, look at that! Look at that!
I think this is a great success. I'm very happy with our circle. I'm way happier with our circle than I'm happy with the line, if I'm being honest.
Even though it's not anti-aliased?
You know, it's the retro feel, I think. The not anti-aliasing really does it for me.
I see.
Maybe when we do another 40 episodes, we'll come back and anti-alias the circle.
Oh, has it really been 40 episodes? That's right, since our last one. Or 30 episodes, something like that. But yeah, we can, yeah. Anyways, any final words before we part ways for a week?
Nothing comes to mind. Do you have any final thoughts?
I haven't made pizza in like a month or multiple months.
This person likes the circleness. Excellent.
Nice.
Rasterizing a spinning square.
Oh,
You're getting close to my heart.
There's I've seen these people do. Somebody was doing a like ray tracing in doing 3D. Like people have done like run Doom on a Flutter canvas and whatnot.
Oh, we could do voxels. We could do like a voxel sphere.
Whoa. I think if we had that much trouble with rasterizing a circle, I will. Wikipedia has plenty of fault here. Both of our learning sources were.
Look, I feel like I understood it in the end. Like all the magic was gone for me. Like I got it. Like the 4x trick was really the key to unlocking what these really weird equations were.
We were also hurt by at least my learning style, which is I'm a skim learner. I have learned, and so the fact that I skipped all the pros that would have explained to me what it was doing got me in trouble.
Well, we'll continue our skim learning next week.
Anyways, have a good night, all.
Good night. See you next week.